Welcome to my YouTube channel chemical.education. Today I'll talk about TXY diagram. I'll show you how to draw TXY diagram using MATLAB. Now I'm taking one question here, and question is, so here is the problem or question. So the vapor pressure of the acetone, that is component 1, and acetonitrile component 2 can be evaluated by the Antoine equation. Antoine equation is given ln that pi star is equal to A minus B T plus C. So that T is in Kelvin and P is in kilopascal. Antoine equation constant, Antoine constant A, B, C, both component acetone and acetonitrile are given. So that and assume that the solution formed by this mixture obeys Raoult's law, and draw a TXY diagram at 100 kilopascal. 100 kilopascal. We have to draw that TXY diagram. Now, Raoult's law. What is Raoult's law? So, Raoult's law describes the vapor pressure of an individual component in a mixture of liquids for a component I in a solution. So, Pi, partial pressure of I component, is equal to Xi into Pi star. So, where Pi is the partial vapor pressure of the component I, Xi is the mole fraction of component I in the liquid phase, and Pi star is the vapor pressure of pure component I. Now, we know from the Dalton equation that total vapor pressure above an ideal solution is the sum of the vapor pressure of each component. So, P total is equal to summation of all partial pressure for individual component. If we take here, in that problem, so binary mixture is given. So, for the binary mixture, P total will be x1 into P1 star plus x2 into P2 star. So, P1 star and P2 star is the saturated vapor pressure. Saturated pressure or vapor pressure. Now, here Antoine equation is given. Now, that total pressure is equal to x1 into P1 star plus x2 into P2 star. Now, we know Antoine equation. So, here ln Pi star is equal to A minus B T plus C. So, if I take that Pi, so that will be e to the power A minus B T plus C. And if we plug all this A, B, C, so we can write x1 into e to the power all this plugging value. Similarly, x2 into that P2 star, so e to the power this value. And we know for the binary mixture, x1 plus x2 is equal to 1.0 means 1, x1 plus x2. So mole fraction of sum of all mole fraction is 1. So now we can write x2 in terms of x1. So this is x1, not x2. This is x1. So that will be x. P total is given. P total is 100 kPa. Now plugging all the known values, we get 100 is equal to x1 into e to the power all this value for the acetone and acetonitrile. So this is also 1 x1. So this is x1. This is also x1. This is the typo mistake. Okay. So that is typo mistake. Now, so we got the equation. So that is 100 minus x1 this, and 1 minus x1 into this. Now we have to solve this problem for different x, and then we will get different t. Now I'll show you in MATLAB how to get TXY diagram. So we have to go to the MATLAB. Okay, now we are solving this problem by using MATLAB. So that is we are solving these problems, means we are going to draw T, X and Y diagram. Now here, so first we are putting CLC for clear skin, CLC, and then clear all. Okay, and then first we have to write that Antoine constant for Antoine equation, Antoine's equation. Okay, so now here we are putting A1 value. A1 is that is, we can copy and we can paste it here. So here A1 is something this, and then B1 is this, and C1 is for this component 1 this. Now for acetone, so that is acetone Antoine constant. Now we can also take that acetonitrile, that will be A2, B2, C2, and then we have to put that comma, semicolon, then semicolon, and then semicolon, and that will be something acetonitrile. Then so P total is given, so P, we can write P total is how much, that is 100 kilopascal, 100. So as that Antoine equation P is in kilopascal, so we don't need to change anything. So that is total pressure in kPa. Next we have to calculate the saturation temperature. So means what will be the saturation temperature for acetone and acetonitrile, means that boiling point of that acetone and acetonitrile at 100 kilopascal. So we are going to calculate saturation temperature. So saturation temperature for pure component at 100 kPa using Antoine's equation, So now we know that Antoine equation, so that will be, we are going to calculate T. So T1 saturate, T1 saturated sat is equal to, so if we do that, so that will be B1 by then A1 by A1 minus, so here log ln is there, log P, so here log P means P total, and then okay, so we have to make bracket here. Okay, we have done, and then plus C1. So now here, so if we do that, so that will be that we have try to calculate that T, so that A1 minus log P total, okay, and then B1 by this, and then what will happen, this will be T plus C, right? Okay, so then it will be like a T plus C or T minus C. Okay, that is T minus C. So B1 by A1, okay, this minus B by this, then T, okay, this is correct. And then also we can calculate this T2, that because we need to take the gauge value, for that we must calculate that the saturation temperature. So now you can get that. Now we can run and we will see that. Okay, now here, now we know that as we got that equation, and from that equation we can calculate that temperature. Now we are taking that x1 range will be lean space, so that is it will be 0 to 1, mole fraction must be 0 to 1, and then 0 to 1, and I am just dividing 10 points. Okay, similarly, what about T liquid? That T temperature in the liquid that will be is equal to just we are taking some zeros values first to store this data. Zeros, that zeros should be 1 to 10. Okay, so for storing purpose means we are just creating that row matrix, and then we are taking the gas value. So ti is the gas value. Ti is equal to, so for solving that equation we need gas value. T1 saturated plus T2 saturated okay, so that is there, T1 and T2, and then we can do that. What we can do then, we can write the Raoult's law. So now Raoult's law, what is that? This is Raoult's law. Okay, this one. So Raoult's law we have to write. So we know that from the Raoult's law we can write, right? So P total or Raoult's law. So we already have formulated this equation. So that will be, means we got the function is here. So that is f that is function. We can write function is at the rate of t, because that is the function of t, capital T, and then we have to write that x1. Okay, so here x1 and I, so lin pace, so we are creating that array. So xi into then this one e to the power something. So that we have to do that, that exp of a1 then minus b1 by t plus c1, that is okay. Then plus same thing, I can copy it and I can do that. So that will be a2 b2 and c2, and then this will be 1 minus xi. Now all these things are, I think, array, so we have to put dot here also we have to put dot here, and then p minus, so 100 minus of this total. Okay, so this is the our equation. Now here we are going to solve, right? Now here we have to use that for loop. So for I is equal to 1 is to, so length of x, x1. So that means we have to do the calculation from 0 at x is equal to 0, x is equal to 1, x is equal to 0.1 to 1. Then we can calculate the T liquid. So that T liquid I, to solve this equation for each x. So that will be f0, you can use f0, then 1, and then gas value Ti. Now end. If we do that, if we run that, we can get that. Okay, so this must be capital X. If we do that, okay, so we got that value. Okay, good. Now we have to calculate y. So calculate y1, right? So how do you calculate that? So we know that pi, or we can p into yi, that is partial pressure. So that is pi is equal to this, is equal to, we can write that x1 into p1 set, that we can write. So now here, so now what will be y1? So y1 is equal to x1, then p1 sat will be here. So exp of this is that p1 sat, and then x1 into p1 sat divided by total p is here, p total, I think. Okay, so that will be, I have to put comment. Now if I run that, we'll get, okay, so here that T liquid, we have to put that T liquid, because T liquid. Now if we do that, I think we'll get, okay, so we'll get all this from, okay. Now we have to plot that. So plotting TXY diagram, so we have to plot the TXY diagram. Now plotting, so plotting will be, so now we can use figure and then we can use plot command, plot. So x1, then T liquid, okay, and then hold on, and next will be plot y1 versus T liquid. Now if we run that, can we get that plot? Yeah, we are getting the plot. Okay, now we can do that some beautification, right? So here I am putting something like this red line, that is a red line, and lined with, I am putting that is some line lined with, we can put that lined with, maybe I am putting 2. Similarly here also we can put something, we can put something like that, but this should be some blue. Okay, if we do that, and if we run, so we'll get that nice plot. Okay, now we have to adjust that limit. Okay, so x limit, so that will be, must be 0 to 1, so that will be 0 to 1. If we run that, we'll get that. Okay, good. Now what will be our y limit? So y limit must be that T1 sat and T2 sat, and T2 sat, because that is the boiling point of two component in acetone as well as. So if we do that, I think I will get that. Okay, now here it is saying something T1 sat and T2 sat. So while limit, here is while limit. So what is that? T1 saturated and T2 saturated. Okay. It must be two element vector increase the matrix value. Now we got that T1 and T2. T1 is this, and T1 saturated and T2 saturated. Okay, so for that, okay, so in the T2 is lower, right, and T1 is higher, so we have to do that, otherwise it will be giving the wrong result, right? I think it is like that. Yes. So now this is the TXY diagram. Now we can put some level, so we can put X level will be X level is the mole fraction, so that is something mole fraction X component X1 and Y1, X1 and Y1, and then Y level, so that will be that temperature, so that is temperature K, and then we also put legend. So first is TX curve and then TY curve, so we can put legend, so we can put that TX curve and then comma, then again, then TY curve. So now if I do like that, we'll get that plot. Yes, good. We'll get that. So this is the TXY diagram. That's it. Thank you.